all we have to do is measure the vial, subtract the vial weight.
Oh, okay.
But this is a little high, so I think we should take a little bit out of those.
Okay. Okay. And you want to
take a little bit out and remeasure them.
Okay.
Because we want it to be under a gram.
Okay.
So you can do that. Just do. We're going to follow the EPA 3050B protocol. This is a protocol for acid digestion for soil, sludges, and sediments. It involves digesting the organic matter and extracting the lead from any undigestible material and suspending it in solution. It's a process that involves us heating it in nitric acid at a nearly boiling temperature and then adding peroxide to fully oxidize the organic matter. That's because when acid and water mix, they create a lot of heat. And if you add acid to water, the water can boil. And if it boils over, then you get acid everywhere. For some reason, if you add the water to the acid, it doesn't boil. I think it's because the water heats up, so there's not as much water to boil. So we're going to add the acid first, and then we're going to top it off with water. So what you're going to do is these transfer pipettes, they're graduated up to 3 milliliters. Each of those tubes needs to have 5 milliliters of acid and 5 milliliters of water. So put the acid in first and then the water. And if we do it like this, there's an even number on either side. So move the acid so it's right in between so you don't have to reach over it. And then you two can do the first round. So you just kind of got to count it up. So that's 3 and then you need 2 more for that one. And that at this point we're going to be up to about 15 milliliters of nitric acid. And we usually don't have to add more than 20.
Is it here?
Ready?
Yes. So we're going to have a flame burning here, and it will spray our sample into the flame. And when lead burns, it absorbs light from specific wavelengths. So without lead, 100% of the wavelength light will make it across. It's 217 nanometers. But when there's lead there, some of that will be absorbed. So it will measure how much is absorbed. So what we do is we have these known standards. We'll create a calibration curve with those, and then we compare all of our unknown samples to the calibration curve. Before we can start, the light bulb has to warm up. It has to sit there for like 20 minutes with electricity running through it. So In the meantime, these samples are ready to run, but we can go dilute the soil samples. We have to filter those also.
That one should be washed off. It was at the bottom.
So I just go. That's about what our flame looks like. For lead, we use a low flame, but if we were doing a metal like cadmium, or so that it knows that we're going to do 6 standards, it's just auto zeroed. That means it's ready to go. So the first standard, this is to, and then someone hit F5 for me.
That's the curve. That's what we're using for.
This one's not going to look any different because it's just, the only difference is that there's more nitric acid and more peroxide in this flame.
Okay. That's good. It's definitely a little bit darker.
And there's definitely lead in this soil. Look at the, we jumped up.
Concentration of lead. Oh, you can see it. Wow. Crazy.
So is this evaporating the liquid?
It's pulling the liquid through the tube and spraying it into the flame. And then the elements in the flame, the different atoms absorb the light. There's a laser that's passing right through the flame from one side to the other.
Very cool.